When we are talking about investment decisions, this is one of the core functions of a finance manager. Among the other functions, the finance manager in any organization has got this particular duty of making investment decisions. But now, what is this that we are talking about investment decisions? Any organization that wants to prosper must invest. And when we are talking about investment, it is where an organization commits a considerable amount of money now with the hope that in the future, that money or that investment is going to generate income to the organization. So you are investing or you are committing a considerable amount, depending on the size of the organization, but the amount that you are committing, it is being committed because you want that money to generate cash flow in the future. Most of the investment decisions that you are going to make will now going to involve the projects. You start a project now, but the hope is that that particular project is going to generate income to the organization in the future. I want you to note that. So, among the characteristics of the investment decision, number one, they require huge cash investment. You are going to commit a considerable high amount of money. Number two, these investments, they normally involve some element of risks. There is some element of risk. Why? Because the benefits will be coming in the future. And we all know that our future or the future is uncertain. So you can either gain or lose whatever you have invested. So there is risk. Number three, the cash inflows will be streaming in. It is going to be a stream. When we are talking about a stream, you are not going to get the benefits as a lump sum. You are going to get some returns in year one, some returns in year two, year three, like that. So you are not going to receive the returns as a lump sum, but as a stream. Then number four, they require what we call priority. Because you might have like 10 viable projects that you want to invest, but you don't have enough capital to invest in all of them. So what do? You prioritize, you rank them in the order of priority, and you start by investing what you need or what you consider to be the most pressing or the most important project as you go with that order of ranking. Then these projects in one way or another, they are going to be beneficial to the organization in future. You find that the value of the organization will be increasing because of this. So this is like the opposite. Instead of having a lot of cash in your bank account, you can convert that amount into investment. The investment will be now generating cash flow into the organization. And that's why it is not very, very viable for you to have a lot of amount in your bank account lying idle. Instead of having them in your bank account, if it is in excess, the excess is normally placed in the investment. Now, when you are making this investment, then as a finance manager, you need to be very careful, especially because of these first two characteristics. You are going to commit a huge amount of money, and there is element of risk, meaning that whatever you have invested, you might lose. And because of that, then there is need for you to do what we call investment evaluation. You need to do what we call investment evaluation so that you can be able to know whether the project that you want to commit the money is going to be viable or not. You need to evaluate your projects. So today, and actually that is the core business of this particular topic. It is the core topic in finance manager. You rarely miss a question on this when it comes to financial management part. So how do you evaluate a project? So broadly, we have got two techniques that we normally use to evaluate projects so that you can be able to know which project is viable and which one is not. So those techniques, number one, they are known as the non-discounting. We have the first category, we call it the non-discounting cash flow techniques. I am very much aware that Mr. Ezra has taught you about the time value of money, whereby you talked about the future value and the present value. So when you are talking about the non-discounting cash flow techniques, these are the techniques that don't consider the element of time value of money. They base the assumption that the amount that you have right now in terms of value is the same as the amount that maybe you'll get after 2 or 3 years to come. So that particular aspect, they don't discount. Remember, the process of discounting, as you are taught, is the process of determining the present values. If you are promising me that you are going to give me 10,000 after 10 years, I can sit down and do what we call discounting. You are going to give me 10,000 after 10 years. Now the question is, if you are to give that money now, it is equivalent to how much? So when I convert an amount that I'm going to receive in the future, I convert it into equivalent amount now, I'm doing what we call discounting. So basically, this first category of techniques, they ignore the aspect of discounting. They assume that the 10,000 of today, in terms of value, is the same as 10,000 after 10 years, which is not true. Because in terms of purchasing power, whatever I can be able to purchase with the 10,000 now, after 10 years, the 10,000 cannot be able to purchase the same item. I'll spend more. So we have said that these projects, the benefits will be in future and will come as a stream. So these techniques, they ignore. Even if I'm going to get a cash flow after 5 years, and it is 1 million, they assume that that 1 million after 5 years is equivalent to 1 million of today. So they don't discount the cash flows. And here we have got two techniques. Number one, or A, is the payback period. Number two, or B, is the accounting rate of return, also known as the A.R.R. These two techniques, they don't consider the aspect of time value of money. So you evaluate the project based on the cash flows as they are. You don't discount the cash flows. So I want us to start with it, but before that, I want to give you the other category of techniques, which is number two, which is now known as the discounting cash techniques. The discounting cash flow techniques now, they incorporate the aspect of time value of money. These techniques, they are aware that money received or paid in different time intervals in terms of value is not the same. If I've invested my amount, I'm going to get some benefits from the project. In future, I need to convert those cash flows that will come in future into present. Year one, I'm going to get 500,000. If I'm going to get that money now, it is equivalent to how much? Year two, the project will generate to me 800,000. If I was to get that money now, it is equivalent to how much? So those future cash flows are converted into present cash flows in a process called discounting. So we don't evaluate the projects based on the amount the project will generate. We evaluate the project based on the discounted cash flows. Discounted cash flows are the cash flows in which you have converted them into present values. Here, we are going to have the following methods. A is the net present value. B is what we call the profitability index. C, we have got now a method we call discounted payback period. And lastly, number D, we have the intern rate of return. This is known as I.R.R. This is known as N.P.V. This is known as the P.I. Then we have the discounted payback period. So in these methods, we must discount the cash flows. We must determine the present values. Then we evaluate the project based on the present value and not based on the cash flows. So with that introduction, allow me to take you through the first category first, and then we move to the second category of the project evaluation techniques. The non-discounting cash flow techniques, number one is the payback period. So the payback period is simply the period or the time duration it will take for you to recover the amount that you invested in your project. How long it will take for you to recover the amount that you have invested in a project. That is what we call the payback period. I've invested 1 million. The project is going to generate some returns to me. From those returns, how long will it take for me to recover back my 1 million? That duration it will take for me to recover back my amount that I invested is what we call the payback period. For any project, in terms of evaluating, if you have got two mutually exclusive projects are those projects that serve the same need. They compete for the same resources, and they are going to provide the same benefits to the organization. We call them mutually exclusive projects. Those projects that you choose one of them, you cannot invest in both. You choose either. It is they are known as the mutually exclusive. So for mutually exclusive projects, you simply choose the projects which will have a lower or shorter payback period. If project A, the payback period is 2.5. Project B, the payback period is 2.3 years. So I will choose project B because it has got a shorter payback period. So the projects with the shorter payback period are considered to be more viable compared to those with a longer payback period. So it is the duration it will take for you to recover your money. But if it is a single project, we are going to have a predetermined or acceptable payback period. So we can say as CHRM College, we want to invest in a project. The management or the board of directors can decide that any project that we are going to invest in, it must have a payback period of less than 3 years. So in that case, what we shall do, we shall have the project. We calculate the payback period. If the payback period is less than the 3 years threshold, we accept the project. If we calculate the payback period and it is longer than the acceptable 3 years, which is the threshold the management has put, then we reject the project when it is a single project. But for two projects, you calculate the payback period for both, then you choose the project which will give you a shorter payback period. So how do we calculate the payback period? You can have a project whereby you want to invest this. This is the cost of investment. Let me say it is shillings 2,500,000. So in simple terms, we want to invest 2,500,000 in a particular project. That project will generate the following cash flows. So the cash flows We have the year 1, 2, 3, 4, and 5. Year 1, the cash flow, maybe it is 800,000. Year 2, it is 700,000. Year 3, it is 1 million. Year 4, okay, for it to be realistic, let me say it is 900,000, sorry. Then here we have got 500,000 and maybe 400,000. That is our project. We shall invest 2.5 in that project. The project will generate these cash flows. Year 1, we get this. So you are told, can you calculate the payback period of the project? For you to compute the payback period of the project, what you do, you will come here and introduce a column we call accumulated cash flows. You will compute or introduce a column of accumulated cash flows. And this is what you do, or this is how you come up with that particular column. So you start with the cash flow for year 1. Year 1, we shall generate 800,000. So you will always start with cash flow for year 1, and then you go accumulating those cash flows downwards. So you will add now 800 plus 700, it will be 1,500,000. 1,500,000 plus 900, it will be 2,400,000. 2,400,000 plus 500, it will be 2,900,000. 2,900,000 plus 400,000, you get it is going to be what? 3,300,000. That is your accumulated cash flow. So that one you need to be careful. How do you get it? You start with the cash flow for year 1, then you now add year 1 plus year 2, you get this. This plus this, you get this. This plus this, you get this. This plus this, you get this. Actually, if you add all this, they should give you the same. The last accumulated cash flow figure should be the same as the total here, because we have accumulated them. Year 1 plus year 2, it is here. So this is for year 1 and year 2. Plus for year 3, you get this. So 2.4 is the cash flow for year 1, 2, and 3. Then you add for year 4, you get this. Year 1, 2, 3, and 4. Then you add to year 5, you get this. So it is the same as adding this, but you need to do it this way. You must have that column. Now, I want to ask you, class, we want to recover our 2.5 that we invested. So you simply go to your accumulated cash flow and ask yourself, where does this 2.5 lie in our accumulated cash flows? So our 2.5, if you look at the accumulated cash flows, it lies between these two figures. It lies between 2.4 and 2.9. So your payback period, therefore, should be equal to, so it simply means up to year 3, because it lies between 2.4 and 2.9, that is between year 3 and year 4. Simply meaning it shall take 3 full years. It will take 3 full years. Up to year 3, we have recovered this. Then we still have 100,000. Remember, up to year 3, the accumulated cash flows that we have received is 2.4. There is 100,000 that we have not received here to make it 2.5. So the remaining amount, which is 100,000, you divide by the cash flow for the next year. Remember, up to year 3, we have recovered 2.4. The remaining 100,000 we shall recover from the cash flow for the next year, which is year 4. And the cash flow for year 4 is this. You divide by the cash flow for year 4, which is 500,000. So that we can know the fraction in year 4 whereby we shall recover this. So you find that this is going to be 3 plus, what is 1 divided by 5, or 100 divided by 500? 0.2. Yes, 0.2. So this is going to be 3.2 years. That becomes your payback period. So you simply you go to the accumulated cash flow, you ask yourself, where does the cost of investment lie? If it is between year 3 and year 4, so it will take, first of all, 3 full years plus a fraction of year 4. How do you get that fraction? You take the amount that has not been recovered up to that particular number of years that you have indicated here. The amount not yet recovered is 100,000, because up to year 3, we have recovered 2.4 and we need to recover 2.5. So we have not recovered 100,000. So that 100,000 that you have not recovered, you divide by the cash flow for the next year. Comparing year 3, our next year is now year 4. You divide by the cash flow, not the accumulated cash flow for year 4, but the cash flow itself for that specific year. You get your payback period. Let me give you an illustration again here. Maybe we have got 2 projects. An organization is considering investing in either project A or B. The cost of investment is shillings 1 million. 1 million, let's say that. Then you will be given the cash flows for each project. So we have project A. We have the cash flows year 1, 2, 3, and 4. That is the cash flows for project A. Then we have project B. Then you are told, can you calculate the payback period for each project and advise the management on which project to invest in? It is simple. So you'll come here and do the accumulated cash flow for project A. Also here, accumulated cash flow for project B. So for project A, the first cash flow is 400,000. 400 plus 300 gives you 700,000. 700,000 plus this gives you 1,200,000. 1,200,000 plus this gives you 1,900,000. That is it. Remember, what we needed to recover is the cost of investment, 1 million. So where does our 1 million lie? Our 1 million lies between these two, 700,000 and 1.2. That is between year 2 and year 3. So our payback period will simply be, you take those, because it is between 2 and 3, meaning that it will take 2 full years and a fraction of year 3. So 2 full years, we have recovered 700,000. So how much is remaining? To make it 1 million, the remaining is 300,000, which will be recovered from the cash flow of next year. After year 2, the next year is year 3. And this is the cash flow divided by 500,000. So this will be 2 plus 0.6. 2.6 years. That is the payback period for project A. Given these cash flows, given this cost of investment. Do the same for project B. Accumulate them. This is 600,000 plus 300, that is 900,000. Plus this one, it will be 1,300,000. Plus this one, 1,600,000. So remember, if you want to recover 1 million, it's between these accumulated cash flows there, which is between 2 and 3. So our payback period will be 2 full years plus. Up to year 2, we have recovered a cumulative amount of 900. How much is remaining? 100,000, which will be recovered from the cash flow for year 3, which is 400,000. It will be recovered from the cash flow for year 3. So this will be equal to 2 plus 0.25. This is the same as 2.25 years. If you are told now, can you advise the management on which project they should invest in? Which project should be invested in? We said you advise based on which one has got a shorter or lesser payback period. If you compare 2.6 and 2.25, this one has got a shorter payback period. So the recommendation would be the management should invest in project B since it has a shorter payback period. That is all. That is all about payback period. That is all about payback period. Any question before I proceed?
I have a question.
Good.
For project B.
Yes.
Is the calculation correct? I have 1.5.
Okay, let us start with accumulated 600. 600 plus this will be 900. 900 plus this will be 1.3 or 1.5 here. 1.5. Huh? That was the issue?
Yes.
But that one will not affect our calculation here. Huh?
Yeah.
Yeah, that one will not affect our calculation because still we shall use 2 full years, 900 has been recovered. The remaining is 100, which will be recovered from this. So we're not using that. That is right. Thank you. So that is how you work out the payback period. This one, we call it the ordinary or the traditional payback period, which does not consider the discounting. We are using the cash flows the way they are. We are not discounting them. It is known as the ordinary payback period. But remember, we have the discounted one. So accounting rate of return will be our second technique. Our A.R.R. Our A.R.R. Just a minute. So for this method, accounting rate of return, it does not use cash flows. It normally uses accounting profit. It uses the accounting profits instead of the cash flow. The difference between profit and cash flow is this. The cash flow is simply the amount that you are going to receive from the project without considering the cost of getting that money. That is the cash flow. If the project year one is going to give me 1 million, the entire 1 million, I take it as a cash flow. But remember, it is different from a profit, because profit, you must take the income minus the costs. So for the cash flows, we don't deduct the costs. We simply consider the whole amount that we generated. But for accounting profit, we need to now subtract the cost of generating that particular amount. So it uses accounting profits and not the cash flows. So for you to get your A.R.R, you will simply take the average accounting profits divided by average investment, or the cost of the project, simple terms. So the average accounting profits divided by the average investment, where average accounting profits, you simply take the sum of profits divided by the number of years. So the profit for year one plus the profit for year two plus the profit for year three, you add them to get the sum of the profits. If the cash flows will be for 4 years, you divide it by 4 years. You will get the average accounting profits. Average investment, you take the costs of investment plus what you call the scrap or salvage value, you divide by 2 for you to get the average investment. This is the amount that we are going to invest in the project. That is what we are calling the cost of investment. The scrap or salvage value, it is the residue value at the end of the project. You know, a project can be an equipment. You have invested in an equipment. That equipment will serve the organization for 5 years. So after 5 years, can you sell and get something from that equipment? Whatever that you are going to get from selling that old equipment after serving you for those 5 years is what we call the scrap value. So this is the value of your asset at the terminal year, at the end of the period you want to use your asset. So that is how you do it. So if you don't have that scrap value in the question, you will simply take the cost of the investment and you divide by 2. So let us have an illustration. So the project costs, let's say it is 1,300,000. This is what you invest in your project. Then the accounting profits, so here you have the year, you have the profit in the table form. Year 1, 2, 3, 4. Year 1, the profit is 400,000. Year 2, it is 600,000. Year 3, it is maybe 400,000 again, and maybe 200,000 in year 4. Those are your profits. 400, 600, 400, and 200,000. Then now you are told at the end, at the end of year 4, the project will have a scrap value of shillings 50,000. Calculate your A.R.R. You calculate your A.R.R. So how do you do it? Simple. Get the average profits. You add, we said it is the sum of the profits, so it is 400,000 plus 600,000 plus 400,000 plus 200,000. You divide by what? I will divide by 4 because this is profits for 4 years. Give me the answer. Then I will also calculate the average investment. We said it is the cost of the investment. The project cost is 1.3 plus the scrap value at the end of the year 4, at the end of this 4th year, which is the terminal year, we are going to have a scrap value of 50,000. You divide by 2. I want you to give me the 2 figures for the average profits and average investments.
Average profit is 1.6.
1.6. 1,600,000.
That's the profit, but I have not divided it by 4 yet.
You divide it by 4, it will be 400. Huh?
Yeah.
So this one is the final answer is 400,000. What about this other one? Average investments. 1,350,000 divided by 2. $1,350 divided by 2. 1,350,000 divided by 2. $675,000. So from there now you can be able to compute your A.R.R. So 400,000 is our average profits. Divide by 675,000, which is you multiply by 100. I forgot here. The rate should always be times 100. So average accounting profit divided by average investment, that is times 100. The rate is always in percentage. So what do you get? $59.26. So that is your average return. Eh? Remember this, the keyword here is about return, average rate of return, average rate or accounting rate of return. So when talking about return, this is what you will get as your returns from your project, and therefore you compare this return versus the cost of the project. If, for example, it is money that you borrowed to invest, you borrowed at what interest rate? If the interest rate, which is called the cost of capital, is less than this, then the project is viable. If maybe the interest was 20%, but you have invested your money and you have received a return of 59.26%. So the return is higher than the cost. So you accept the project. And also sometimes the institution or the organization can give you the threshold. They can tell you that we only invest in projects which give us a accounting rate of return of not less than 60%. If it is less than 60, you reject that project. If it is above the 60 or the threshold, you accept it. So it is going to be guided. So when you are told advise the management, you compare with the cost or the management established threshold. So those two are known as the traditional or the non-discounting methods of project evaluation. So as you can see, there is nothing we are doing with these figures. Even if the money will be coming in the future, we use that figure as it is. We simply add it, and the assumption is that even if this one was received in year one, it is the same as this one that was received. In terms of value, they don't change with the time. They are known as the non-discounting. So we are now moving to the next category of the techniques, which we call the discounting. And by discounting, before we start on them, just a reminder of what you did on time value of money. A simple reminder, when you talk about discounting, this one means you are determining the present. The process of determining the present values is what we call discounting. And when we are talking about of determining present value, then it simply means that the money is in future. So you want to convert it into present. Because we are making the decision now on whether to invest or not. So we need therefore to know in terms of the cost, this is money that we are going to invest. Then if we are going to invest this money, what will be the equivalent returns? So those returns which are meant to be received in the future, you convert them into present so that you can have both of them at present. This is what I will invest right now. This is what I can get. If I was to get it right now, this is what I will get. So you convert both of them into present. So those future cash flows, you convert them into present. Then you can be able to compare. This is what I can invest right now, and this is what I can gain right now. Even if the cash flows are in the future, you convert them into present because the decision is being made now. So for these methods, or for you to get the present value, the PV, you normally take the future value, which is FV, you multiply the present value interest factor. That is how you convert them. The PVIF, this is the present value interest factor of a particular rate of X%. It can be 10%, 5%, 8%, depending. That one you will be provided in the question. So, and it is also known as the cost of capital. So X% here is cost of capital. Then you also need that to know that the PVIF is going to be either be obtained from the table or you can calculate them. So you can use this. We normally say it is 1 plus R% raised to power negative n, or it is the same as 1 over 1 plus R raised to power n. You can use either this or this to get the PVIF. So what am I trying to say? If you have got the project with the following cash flows, year 1, 2, and 3. These are the cash flows. Year 1, you will get 100,000. Year 2, you will get 200,000. Year 3, you will get 300,000 for illustration. You are told the cost of capital is 10%. And then you are told, can you determine the present value for this particular project? So it is going to be very simple. You come here and do the present value interest factor. We are using 10%. Now, instead of X%, you say 10%. Then you are going now to determine the present value. Once you have understood this, then it is going to be a walk in the park. So you can either use this or the table. And I want to believe that you are shown how to do with the table, or I'm going to share a table with you on how to get them. So for you to get this, you can use this or this. It gives you the same answer. You can say 1 plus 10% raised to power negative n. N is the period. Remember, this money will be received after 1 year. So you put power negative 1, power negative n, here it is negative 1. This one will be 1 plus 10% raised to power negative n. Our n now is the number of years it will take for us to recover this. So it is negative 2 because it is 2 years. This one will be 1 plus 10%. This one will take 3 years for us to get this. You put times power negative 3. Can you compute them? Kindly assist me to compute them and give me the answer in 4 decimals. The answers for PVIF is normally in 4 decimals. So can you do this? Remember 1 plus 10%. Don't do 1 plus 10% to get 11%. So note this. 1 plus 10% is the same as 1 plus 0.1, which is the same as 1.1. Note that, because I've seen other cases whereby a student does 1 plus 10%, he says that it is 11%. No. 10% by itself, it is 10 over 100. And 10 over 100 is 0.1. So it is 1 plus 0.1. You need to divide this percentage. 10 divided by 100 is this, so it is 1.1. So you will do 1.1 raised to power negative 1, 1.1 raised to power negative 2, 1.1 raised to power negative 3. Class, are you able to give me those factors? Give me so that we can proceed. .9091. 0.8264, 0.7513. Those are the factors. You convert them into 4 decimals. And the reason why I want you to understand this, in the exam, you can either be given the table or not. If the table is not provided, this is the only savior. You need to remember this. You either do using this or this, they will give you the same answers. So it is going to be like, if you want to be on the safer side, just know how to get these factors, both using the calculator and using the table. With the table, it is very easy because you'll be reading them. But when the table is not provided, you know you cannot go with the table or with your own table to the exam. You don't carry your own materials. The only thing you carry is your calculator and your pens. You cannot carry anything else. So if the table is not attached in your question paper, then you simply use your calculator. To understand this, 1 plus r raised to power negative n, or you do 1 divided by this, the same answer will be derived. Then for you to get the present value, remember these are the cash flows. For the 2 methods that we have just discussed, the payback period and the A.R.R, we were using this without discounting. But now we are doing the discounted cash flow techniques. We need to get this. The P.V, the P.V actually, this is now the discounted cash flows. The P.Vs are simply your discounted cash flows. These are the ordinary cash flows without considering the time value of money. You have now considered the time value of money. You have now determined the discounted cash flows. So you will simply come and multiply cash flow times the PVIF, you get the PV. Yeah? So this one will be 90,910 200,000 multiplied by 0.8264. You get 165 to 80. The other one now, it is 300,000 multiplied by the factor 0.7513. You will get 225,390. So these discounted cash flows now are the ones we use to evaluate now the project based on that second set of techniques. All of them we shall be using the discounted, but you need to know how do you discount the cash flows. You simply take the cash flows, you multiply by the present value interest factor of a particular cost of capital. In our case, it is 10%. So this is how you get the factors if you are using the calculator. But if you are using the table, let me share a table with you. Okay, look at the table that is on your WhatsApp group. Look at the table that is on your WhatsApp group. That is what we call the present value table. And the examiners, they can attach that table with your question paper in your exams, or they can fail to attach it. And that's why I'm saying, if they don't attach it, you get the PVIF using the calculator using this formula. But if they attach, you simply read them. You simply read them. You don't have to calculate them. So you will simply go, that table has got this format. At the top here, we have got the cost of capitals in percentages. So we have 1%, 2%, 3%. It proceeds like that. We have 10%. It proceeds. Then here, on the left margin, you have the periods. So you have period 1, 2, 3, 4, 5. This is normally the years. Year 1, year 2, year 3, year 4, year 5. So it is very simple to read this table. You will simply go to your cost of capital, which is in this case, it is our 10%. So we shall use this column of 10% because that is our cost of capital. So if you read or you go down that column, you have 0.9091, 0.8264, 0.7513, 0.6830. Yeah? Those are now the factors. And this is what we have here. For period 1, it is this. That is what we have there. For period 2, it is this. That is what we have here. For period 3, it is this. That is what we have here. And it continues like that. So you simply pick those and you put them in this column of PVIF. If you are told to use the cost of capital of 12%, you use now the column of what? 12%. You read those factors down here. Remember, it is point, so it is 0 point. All of them are in 0 point. Don't use the figures without having that point, 0 point. So when it is the table is provided, you read direct. But when it is not provided, you calculate them. And note I've said, when you calculate them, the answer you get, you convert it into 4 decimal places so that they can be compatible with the table. So that is it. So under this, we have said, we have got the following techniques under the discounted cash flow techniques. I want to be brief because once you have understood this, how to get the PV, then that is all. Now it is a matter of putting the formula. Once you have understood this, it is now the formula. So the key thing is understanding how to get the present values, which is your discounted cash flows. If you are able to do that, then from one method to the other, it is just the formula that will be applying, but all of them you will be using the PVs. All of them you will be using the present values. So I want to start with the first one, A, which is known as the discounted payback period. The procedure is the same, only that it is the same with the previous payback period, only that with the previous payback period, we were accumulating the cash flows. But the discounted payback period, when it comes to accumulated, we accumulate the present values. We don't accumulate cash flows. We accumulate the present values because these are the discounted cash flows. And the method is known as the discounted payback period. So you use the discounted figures to determine the payback period. So what you do, you are going to accumulate the pre-PVs. So for the sake of time, let me do it. This is 90, 910 for year 1 plus the PV for year 2. 91, 910, sorry, plus 165 to 8. You get 256, 190. Plus now this, you get 481, 580. Let us assume that the cost of project was equal to what? Maybe 400,000. That organization was to commit 400,000. So what will be the discounted payback period? So your discounted payback period would simply be, you just consider your 400,000 is between which two accumulated PVs? It is between those two, 256, 190, and 481, 580. So it is going to be what? 256, 190, it is after 2 years. It is 2 full years plus. After that, we have recovered 256, 190, and we were to recover 400,000. So how much is remaining? My 400,000 minus 256, 190. So the remaining amount not yet recovered is 143, 180. You divide by the PV. We normally now divide by the PV for the next year. So for year 2, we have recovered these. So the remaining amount will be recovered from the PV of the next year. Remember, for the other one, we used to get from the cash flow of the next year. Now you don't use the cash flows, you use the discounted, the PV for the next year, which is 225, 390. So this will be 2 plus 0.64. 2.64 years will be our discounted payback period. So it is almost the same as the ordinary. The other one, we call it the ordinary or the traditional payback period. This one is now the discounted. The difference between the two, we have said. For the ordinary, you accumulate the cash flows. But for the discounted, you accumulate the PVs, which are your discounted cash flows. That's that. Nothing more about it. And that's why I said, for the discounted cash flow techniques, the key thing is to understand how to get the PVs, because all of them, we evaluate them using the PVs. We don't evaluate them using the cash flows. Well, any question on that? I want to run away from that, because that is simply an extension of what we have done. Muko sawa about the discounted payback period? Mother, are you okay?
Yes, I am. Following.
Yes.
Good then. If you are okay with that, that method is okay. And okay, remember you can be given two projects. If you are given two projects, you do the same. You do for project A, for project B, using the same approach. Then you compare the discounted payback period. We said when you have got two of them, you pick the one which has got a lower payback period or a shorter payback period. So that one is covered. Number two, it is a method we call what? Net present value, N.P.V. I don't know why this one is very common in exams. Huh? So for you to get your N.P.V, you will simply take the total present values or PV, you minus the costs of project. The N.P.V, the total present values, you divide by the cost of the project. So what you will do, after getting your PVs here, you add them. You add them. You add all the PVs. And you will realize that if you add them, it is going to give you the same as this, the last figure for the accumulated cash flow. The total PVs is like that. If you add them, they should give you that figure. 481,580. So it is the PV for year 1, PV for year 2, PV for year 3. You get the total PVs. So your N.P.V will be the total PVs, which is 481,580. Remember, we said here the project cost, we assumed it to be 400,000. So you minus with the cost of the project, 400,000. So this becomes your N.P.V. That one becomes your N.P.V. You simply take the total PV, you minus the project cost. How much do you intend to invest in that project? You get your N.P.V. Let me do the other one, then we shall do I.R.R. later. C. This is the method we call profitability index, commonly denoted as the P.I. P.I, you get it this way. You get by the total present values. Now you divide by the costs of project. So the difference between N.P.V and P.I, for N.P.V you minus the cost, for P.I you divide with the cost of the project. So this one will be 481,580. That is the total present values, but now instead of minusing cost, you divide by the cost. divide by the cost. You divide by the cost. So 481,580 divide by 400,000. You get 1.2 or 1.21. 1.21. That is your profitability index. But I want you to note this because in most of these cases, you will be told to advise the management. In all this, you will be told to advise the management on whether to accept the project or not. So for N.P.V, any project with a positive N.P.V is viable. Any project that gives you a positive N.P.V, that project is viable. You can advise the management to invest in it if it is a single project. But if they are mutually exclusive, maybe you have project A and B, project X and Y, and you are told to advise the management on which one to pick. So you advise on the one which, if both of them have positive N.P.Vs, you advise on the one with a higher positive figure. You might find that project A has got this N.P.V, but project B has got an N.P.V of 100 and maybe 20,000. If both of them are positive, pick the one with a higher N.P.V. But if a project has got negative N.P.V, that project is not viable, it should be rejected. And if both of them are negative, you reject both. Any project with negative N.P.V should never be accepted. Even if you are told, advise the management on whether to accept or to invest in X or Y, and both of them are negative N.P.V, advise the management not to invest in any, because both of them are loss-making. That is on N.P.V. In terms of profitability index, any project with a P.I., any project with a profitability index greater than 1 is viable. Any project with a profitability index greater than 1 is viable. You can advise the management to invest in it. Like this one is viable because this is greater than 1. But any project whereby you find that the P.I. is 0 point something, that figure is less than 1, you reject that project. So that is the criteria. P.I. greater than 1, invest. P.I. less than 1, reject. If both of them are less than 1, reject both. If both of them are greater than 1 in terms of P.I., accept the one with a higher P.I. I want us to do one question probably, whereby we are going to use the N.P.V and the P.I. For the discounted payback period. Now that we have done the payback period, I think that will be enough. So, I want to be a bit fast because we have got the internal rate of return still remaining. Internal rate of return. So you want to invest in 2 projects. Let me have first of all the cost of projects is Kenya shillings 5 million, for example. This is what you want to invest, but you want to invest in either project X, which has got the foreign cash flows, that is project X. Or you can also invest your 5 million in project Y, that. The cost of capital so the question is, can you determine the N.P.V and P.I.R.R? I'm going to use the same question to compute the N.P.V and P.I.R.R for each project. So for calculating the discounted cash flow techniques, you need to discount these figures. So you need the PVIF for 12% because that is our cost. Then you calculate the PV. For this project as well, PVIF of 12%, then you determine the PV. So the PVIF, they will be the same. The factors will not be changing. And I want us to pick them from the table. But I've told you, if you are not given the table, the PVIF for this case, you could have determined them plus by 1 plus 12% raised to power negative 1 negative n if the table was not provided. So this is the same as 1 plus 0.12 raised to power negative n, which is the same as 1.12 raised to power negative n. So here you could have done 1.12 raised to power negative 1, 1.12 raised to power negative 2 for period 2, 1.12 raised to power negative 3, like that. That is how you could have obtained the PVIF if the table was not provided. Because we are using the same here, so the answers that we get here, they will be the same here. Now, I want to use the table because it is a bit faster. So I'll just go to the column of 12% and read the factors, which is 0.8929. This other one, 0.7972. 0.7118, 0.6355. Those are your PVIFs. Those are your PVIFs. So how do you get the PV? Cash flow times the PVIF. So you need to get the total here. It's 5,841,650. The total present values for project X. So the PVIF, I've told you they will not change for both projects. Again, you total them. Those are the total PVs. So if you are calculating the N.P.V and the P.I for each, so the cost is 12%, let me have that. For N.P.V project X, N.P.V we know is the total present values, 5,841,650. You minus what you are investing, 5 million, sorry. So this one becomes to 841,650 for project X. In terms of PI for project X, it will be 5,841,650. You divide by the 5 millions. In terms of PI. This is 1.17. That is the PI, 1.17. We go to project Y. N.P.V is the total present value, 6,440,400 minus the 5 millions that we want to invest, which will be what? $1,440,400. In terms of PI, you divide. In terms of PI, you divide. $1.29. So that is how you get both the PI and the N.P.V. So you can be able now to evaluate which project is better. Huh? This one is better in both aspects. N.P.V for this is positive, this one is positive, and we said when both of them are positive, you advise the management to take the project with higher N.P.V, higher positive. It must be positive. If both of them are negative, we reject both. But if both of them are positive, take the one with a higher positive N.P.V, project Y. In terms of PI, this is 1.29, this is 1.17. This one again has got a higher PI. And obviously, if a project has got a higher N.P.V, it will automatically have a higher PI. So if it is PI, still it is project Y, because it has a PI greater than 1, and that PI is greater than the PI for project X. That is it. Anybody with a question on PI and N.P.V? PI and N.P.V. So the key thing is how to get this PV. And for you to get this PV, you'll be able to know how to get that. You should be able to know how to get the PVIF at a particular rate. Once that is done, it is sorted. It is just now a matter of remembering the formulas. So allow me to take you to the last technique. The internal rate of return, I.R.R. internal rate of return. That is the fourth method. The I.R.R. With the I.R.R, remember it is a rate. The rates are always in percentages. So I.R.R, you say that it is a rate that equates total present values with the cost of a project. It is a rate that equates total present values with the cost of a project, i.e., at I.R.R, the total P.V would be equal to the cost of project. Therefore, at I.R.R, N.P.V is normally equal to 0. It is the rate. Remember, the rate is what we are using, what we are referring as the cost of capital, 10%, 12%. If you use that rate, the total PV that you are going to get will be the same as the cost of the project. They will be the same. So that rate, which when used to discount the cash flows, the total PVs will be the same as the cost of the project, is the rate we are referring as the I.R.R. And we are saying, because the total PV and the cost of the project, they will be equal, it simply means that the N.P.V will be 0. Why? Because N.P.V is equals to the total PV minus the cost of project. That is what we know. Yeah? But these two, they are equal. They are equal. So if it is 10,000 minus 10,000, it will give you 0. If it is 100,000 minus 100,000, they are all equal. Yeah? So when you subtract two values that are equal, you will get 0. So at that I.R.R, our N.P.V is normally 0. So the key thing now, how do you determine that rate that equates the total PV with the cost of the project? It has a formula, and I.R.R is computed by, we call it raw discounting rate, R.R plus, put a square bracket. I give you the meaning for this. N.P.V at R.R divided by N.P.V at R.R minus N.P.V at H.R. Then you multiply by H.R. minus R.R. That is how you get your internal rate of return. So R.R. simply means lower discounting rate. H.R. stands for higher discounting rate. All right. So for I.R.R, you will have to calculate N.P.V twice. You will have to calculate N.P.V twice using a lower rate. This is the cost of capital, and using a higher rate. So for example, before we go to a question, you have been told to calculate the N.P.Vs, or you have been told to calculate I.R.R at say 10% and maybe 25%, for example. You have to calculate twice, at a lower rate and at a higher rate. The lower rate in this case is 10%. So you'll get the N.P.V using 10% for a project. The same project, you will determine the N.P.V using 25%. So you'll have two N.P.Vs. You will have N.P.Vs that you have calculated using 10%. That is now the N.P.V we are talking about here as N.P.V at lower discounting rate. And the N.P.V at lower discounting rate will always be positive. So for example here, for 10%, your N.P.V was 11,600. When you used lower discounting rate of 10%, your N.P.V was 11,600. Then you calculated the N.P.V for the same project, but this time around you used 25%. So when you use the higher rate, the N.P.V will normally be negative. The higher rate, the N.P.V will be negative. Let's say it gives you negative 3,200 when you use 25%. Then now you are told, can you determine the I.R.R? Now you will subject that one or these values into your formula. So your lower rate, this is your lower discounting rate. 25% becomes your higher discounting rate. You will come here and say your I.R.R will be equal to lower discounting rate, which is 10%, plus N.P.V at lower discounting rate. At 10%, our N.P.V is 11,600 divided by N.P.V at lower discounting rate. It is the same, 11,600 minus, and this is the point I want you to be careful, minus. But also remember, the N.P.V at higher discounting rate will also be negative. So you'll have two negatives there. The minus that is in the formula, minus or times this negative that is here, minus 3,200 . So minus, it is what we have here, and this negative that is in the N.P.V. Then you will be multiplying by higher discounting rate minus lower discounting rate. Higher discounting rate is 25% minus lower discounting rate 10%. So this will give you 10% plus 11,600 divided by negative and negative. You all know it is positive. 11,600 plus 3,200. Then you will be multiplying by what? 25 minus 10 will be 15%. So this is 10% plus 11,600 divided by, this one will be 14,800 times 15%. So I'll do 11,600 divided by 14,800. I'll get 0.7837. I just multiply by 15. Just multiply by 15 because at the end of the day, the answer must be in percentage. So don't change this one into 0.15. Multiply by 15. You get 11.776%. that becomes your I.R.R. So you have to do it twice, using a higher rate and a lower rate. Lazima upate N.P.V mbili. For the higher rate, it is going to be negative. For the lower rate, the N.P.V will be positive. So what I want to caution you is this. If this question is brought in your exams and you have not been given the rates, because it is possible, you might not be given the rates. You have been given the cash flows and you have been told, calculate the I.R.R. No higher rate, no lower rate. So you just assume, you just do assumption. Actually, you assume a lower rate. You can take 10%, 8%, 9%, a lower rate. And then you pick a very higher rate, like for example, 25, 30%. When you are picking the higher rate, don't just go slightly higher. Just go the highest. Because if you are using 10% and then you choose your higher rate to be 15%, most likely, even that 15% will give you another positive. For you to calculate I.R.R, you must have a negative N.P.V and a positive N.P.V. Because we have said at I.R.R, N.P.V is 0. And it is 0 because it is between a positive and a negative. It is somewhere in between here. You cannot have positive and positive. N.P.V, one of them must be positive, the other one must be negative, so that you are looking for a rate that can give you 0. 0 is between negative and positive. 0 cannot be between two positives. 0 cannot be between two negatives. It must be a positive and a negative. So if the rates are not given, which is rare, pick a lower rate, like 8% or 10%. But when you are picking a higher rate, don't just go slightly high from 10% to 15 or 13%. Pick the highest so that you don't, it relieves you the burden of doing it again and again until you get negative. So if I were you and I was provided with a table, I'd go with the highest, like 32% to be my higher rate. And remember this, even if I use 8% and 25%, you use 10% and 30%, we shall arrive at the same answer. As long as you had a positive N.P.V and a negative N.P.V. So when you are selecting your highest rate, pick the highest. Because once you pick 10 and then you get it is positive. You pick 15, you get it is positive. You know that 15 does not work. You need to recompute again. You need to be going higher until you get negative. That is when now you can subject the figures into the formula. So when picking high rate, go to the highest so that you avoid redoing it again and again. So very fast, I want maybe to demonstrate with a question. I pick a question that is not having a lot. Let me pick from what we have. From the document that I shared yesterday evening, we have not used it, but I hope at your own free time, you can be able to use the questions for your own revisions because they have everything. Because they have everything. So I shared, yes, yesterday evening, there's a document on time value of money and investment decisions, past paper questions. Proceed to the last question, question 18. The last question requires you to do N.P.V using 15 and 24%. You have been told to get the N.P.V using 15 and 25%. So 15 is your rate. So you just come here and do PVIF for 15%. Then you get the PV using the 15%. Then you repeat the same question now. You will come here and do the year 1, 2, 3, 4. The cash flows. The cash flows remain the same: 300,000, 900,000, 400,000, 100,000. Now you do the PVIF using the higher rate. PVIF of 25%. Then you shall get the PV for that rate. That is what I was telling you. Yeah? You will have to do N.P.V twice for the same project. So I will just proceed to my table and read the present values interest factors. Starting with 15%. $0.8696, 0.7561, 0.6575, 0.5780. Those are for 15%. For 25%, I will just go to the table of, they have not provided 25% for the table. So that one we need to calculate. The factors are not in the table. 25%, they are not there. So it will be 1 plus 25% power negative n, which is the same as 1 plus 0.25, which is the same as 1.25 power negative n. So what I'll do, for year 1, I'll do 1.25 power negative 1. This is 0.8. $0.64, 0.512, 0.4096. You can make them to be 4 decimals by adding the zeros. Then your work will be very simple. This times the factor gives you this. Get to the total PV. To 60, 860, 8, sorry. get the total PVs for the same. Then you add them. We need to calculate the N.P.V for the two projects. We need to calculate the N.P.Vs for the two projects. So we will add the PVs. Get 1,261,550 for that. Anybody with the answer for this? Totals? Do that.
1,000,000.
Sorry, come again.
1,061,760.
061,750.
760.
Okay. So those are the total PVs. So we can get now the N.P.V at this 15%. Remember, 15% will be our lower discounting rate. You will take 1,261,550. You minus the amount that was to be invested in this project. This project was to be invested an amount of 1,100,000. You get 161,550. That is the N.P.V at 15%. So the N.P.V at 25%, which is now our higher discounting rate, will be equal to 1,061,760 minus the cost, which remains to be 1,100,000. Which becomes negative 38,240. And that is the point I was deriving. At higher discounting rates, the N.P.V will be negative. At lower discounting rate, the N.P.V should be positive. Once you have a positive N.P.V and a negative N.P.V, you can now be able to determine the I.R.R, which is now the rate between this 15 and the 25, whereby our N.P.V will be 0. So the formula says what? The formula says for you to determine the I.R.R, you take the lower discounting rate, you add N.P.V at lower discounting rate, divide by N.P.V at lower discounting rate minus N.P.V at higher discounting rate. After determining that, you will be multiplied by higher discounting rate minus lower discounting rate. So you just substitute. Our lower discounting rate is 15% plus N.P.V at lower discounting rate, which is 161,550 divided by N.P.V at lower discounting rate is the same, 161,550 minus the N.P.V at higher discounting rate, which is also having a negative. So you put that negative 38,240 multiplied by higher discounting rate is 25% minus lower discounting rate is 15%. So this one will give you 15% plus 161,550 divided by, I said negative and negative will change that one to be positive. So you add the two of them. $161,550 plus 38,240, you get 199,790. Then we shall multiply by what? 25 minus 15 is 10%. So at the end of the day, you get 15% plus, work out this divided by this, you get a figure. Whatever you get here, you multiply by 10. You will get 8.09. This is also percent because this one was percent. 23.09%. That is your I.R.R. So basically, that is how you compute I.R.R. in case it is tested. You do two N.P.Vs with a lower rate, with a higher rate. The lower rate should always give you positive N.P.V. This is the N.P.V using a lower rate, which is 15. This is also your N.P.V using a higher rate, which is 25%. When you subtract them into the formula, you will get, and actually your I.R.R. should be somewhere between the two rates that you have used. It should be between the lower discounting rate and the higher discounting rate. It should always be somewhere in between here. So this is the answer. So that is investment evaluation techniques. So there is some theoretical part of it about the advantages and disadvantages of each method and all that. And all those materials, you'll find them in the LMS. The LMS on investment decisions, I provided all those materials, the advantages of payback period, the disadvantages of that. Also try to interact with them. But on the computation part, we are done. Any question from today's class?
Mwalimu,
Yes, Valentine?
during exams, are
Yes.
the formulas provided? You are expected to know the formula.
Are what provided?
The formulas.
The formulas are not provided. The formulas are not provided. So make an effort of doing as many revisions as possible so that the formulas can stick. They are not provided. Any other question? Well, if there is no any other question, probably we might meet on Saturday evening and Sunday so that we can finalize. I want us by next week on Thursday we finish everything. So on Saturday 5 p.m. we can meet for 1.5 hours or so to finish on one of the topics that is still pending. Then whatever that will remain, either we finish on Sunday, or if we don't finish on Sunday, we can have our last lesson on Thursday. But we can as well have a class for revision on next week weekend, based on how the schedule will be. So be prepared psychologically to have a class on Saturday 5 p.m., then Sunday 4 p.m. as usual. Otherwise, asanteni sana, enjoy your day. Bye-bye.
Bye. Thank you. Good day.
Bye.
N.P.V.